that's working. Anyway. Hi, welcome back to week 2. What the heck did we do in week 1? Unity game programming. What was this course all about? We had a big vote for what game we want to make. We decided it's going to be an action RPG or something. We didn't come up with a name yet, but that's okay. And we're going to use a certain design philosophy in our code so we can make things happen quickly and easily and with a lot of quality control on the pieces that we make. What's the philosophy we're taking? Here we go. And the idea is this. Your scripts should do one thing and one thing only, and they should communicate with other scripts. And we're going to model our problems. This is like the next step in OO, but we're going to model our problems in terms of conditions and responses. Right? So there are a number of conditions. There are things we can check for when we're writing game logic traditionally, and there are a number of things that can happen as a consequence of that. And if we build these pieces out of model behaviors, and we can leverage the fact that model behaviors can be attached and detached to game objects on the fly, and we got a unique form of polymorphism there because we can specialize and change the behavior of the object rather than having to recompile. And anytime you can take work out of the compiler and put it into the game engine, it's a good thing. And if the reasons for that aren't clear, I can talk about that later. So what did we do last time? We built up a few classes. We have something for isPlayer to describe the primary hero who's going to interact with things. We came up with a base class mixin, which we're going to use for these pieces that we're creating. And we created a couple others. We created a consumable, which kind of self-destructs. It wasn't as far as we want to get with consumable, but it means we have an object that can be consumed. And consumable objects respond to, or could respond to any number of conditions, right? But the one condition that we implemented was touchable. So our consumable object consumes itself when it's touched. And in our implementation of that, we use the onCollisionEnter callback method, and we have a couple parameters, touch type and not touch callback. So if I'm touched by something of a certain type, meaning I'm responding to the thing that I want to respond to, then invoke some message. And that message is inside the consume component. So our diagram actually looks like this. This is our whatever pickup thing. It has a is consumable, and it has a is touchable. Pretty simple. It also has a transform and a mesh and stuff like that, but as far as logic goes, that's what it is. And we can make a prefab of that, and then we have Pac-Man bullets that we eat, and they go away. Let's take this further, shall we? What else would it be cool for our pickups to be able to do? Can we sell this for $0.10 on Steam yet? No. Probably 8 cents. To get to 10, what would be cooler? Incrementally cooler to picking up an object and having it just disappear.
Add it in inventory.
Add it in inventory, we're maybe by the end of today, if we're lucky.
Pick it up.
We should pick it up and maybe attach it, maybe like grab it. If we had an avatar, we can do that. I definitely want to plan to get there today, even more simply. Let's think about attributes. So the things we pick up should be able to impact us as well as impact themselves. So it destroys itself. It doesn't do anything to us. It doesn't add to our gold count. Right? It's not a coin. It's not a health. What's that?
Change your color.
Change our color?
Yeah.
We can do that.
Gives us more health, or like could make it slightly bigger.
It could be a scale up thing for sure. And we can do that too. In fact, I'm going to do those two. I'm going to start with another one because we need some more tools in our toolbox before we can do those things fully. Because we're going to scale up. We're going to want to have a property for how much we should scale up, right? And if we're going to change the color, we're going to want to have a property for what color should we scale to. And so to do that, we need the concept of properties. We have properties in C#, right? But since we're dealing with model behavior as a wrappers for our mixins, how would you do that? Unless you use reflection. How would you get a property with a certain name? It's kind of hard. So in our system, it means we need to have something else, a property or data that we can attach to our object, because not all objects are going to have all attributes. These things are going to be added at, or removed at design time or at runtime, so they have to be model behaviors. Agreed? Just like these other things, just like these conditions and responses. So we need another concept. And that concept is I don't know, data. So it could be how much to scale up by, it could be what color to change to, but I want to use a simple data type to illustrate this concept, and so I'm going to use int. If we can attach integers to objects dynamically, then there's some interesting things we can do. So if we're going to want to attach an int, we're going to say we're going to have a type called an int data. Come back here. Sure. Int data. All right. Int data is a what? Mix in. And it's going to have a value. The actual value. And it's going to have a, do mixins have name yet? I forget, did we put a name on mixin? We did not. So I'm going to go back to mixin, and I'm going to say public string. There is a property on model behaviors in game objects called name. Is it capital N or lowercase n? There is a thing in Unity called .name, where you can name a game object. Is it a capital N or a lowercase n? Is it lower? So should we have a different name for this? We don't want it to collide with the Unity name. First name. So it's a unique identifier. So we're going to name, let's say this is an int data. The idea is this. The user case is this. It's going to have a container for a value, maybe that's 7, and it's going to have an identifier, which is a string, and maybe you're going to call that score. Or maybe, you know, on the player, you're going to have another property here called score. So if the player has a score, if it interacts with something that changes the score or has that attribute, we're going to bind the two by name and apply a modifier. So what's a good generic name for this property that describes the name of the thing if we don't want to use name? Key? Key? Sure. Is that a reserved word? No? Sweet. So we'll say this is the unique identifier name GUID of the mixin. All right. Sure. All right. So our data has a name and it has a val. That's cool. So let's go back to our pickup. I'm going to duplicate this, Control D. I'm going to call this coin because I think in our RPG we're going to want to have gold so we can spend it on stuff. Agreed? All right. So this gold coin, not coin. This gold coin is touchable, it's consumable, and it's going to have a value. So I'm going to add a component, which is an int data. This attribute also needs its value. That needs to be public so I can see it. If I go back here, the name of this property, that is how much gold this gold coin is worth. Let's call it gold. It doesn't have to be all capital. I don't know, I'm feeling all caps today. Gold, lowercase. And how many gold pieces should this gold coin pickup be worth? 5, there you go. Why not? It's a small pile of gold. Sweet. So now this gold coin, we can walk into it, we can interact with it. It has an int data, but nothing happens with that. We want this gold to go somewhere. We're just going to go on the player. So we're going to add another one. And we're going to say the key is what? Gold? G-O-L-D? Okay. So now the coin has gold and the player has gold. All right. So we're gonna do it by name matching. Why? Because designers are good at creating strings for names of things. It's easy. Maybe we'll change this with some editor scripting and make it a little bit more friendly, but it's something that non-programmers can manage, right? When do we want the player to? How is the player going to interact with this coin? Tell me a story. When should the player's score increase itself? When I touch it. All right. So it's a consumable object. When we consume it, it self-destructs. Is that what we want to happen? Do we want our coin to self-destruct and then add its score to the player? Sure, why not? It's gone, right? It's gone into your inventory. Maybe later we'll want to have it actually in an inventory container. We'll have to have a container mix in or data type that we can interact with objects with. So let's say this thing goes away. If it has an int data, we want to do something with it. Check for any, call them buffs. How do we know? And we should probably do this before the destroy, even though it's not going to resolve until after that function. Conceptually, that's a bit better. So when we interact with this thing, when we consume this thing, however we're consuming it by touching it. However we consume this thing, because it's a gold coin, because it has a value, a property called gold with a value, we want to translate that value to the player, because that's the interaction we're implementing.
So we should probably check first if it's colliding with the player specifically.
But we know it is,
Or we don't.
because we're going to consume. So our designer has that condition, and we don't even care about the condition. As far as what it means to buff an attribute, it doesn't actually matter the reason why we're doing it. Just to buff something means to add the value. Agreed? So what do we need to know?
Where it's stored?
We do need to know where it's stored. Then where's that stored?
In data.
We need data. Okay. So we need to check for any attributes that match by name to the player. If they match, apply the delta. So to do this, so real simply, what does that mean? And I'm going to use that in case we have a hierarchy. Unless we want to assume a design model of constriction that all these attributes are going to be on the root object. Can we guarantee that? Are all these aspects going to be on the root object? Maybe, maybe not. Something like that. Now, how do we know? How do we know if we should apply this? How do we know if we should apply any of these, to be more specific? If you had a variable called life and another on the object, and another variable called stamina on the player, should you add the life to the stamina when it's consumed? No. We should do it when? Having trouble hearing.
We would have to loop through the initial data and see if it matches.
Sure. For each. What is it? Key equals what? What are we trying to do? We're asking ourselves. Do these match my name? So how do we connect that?
We have to get all the into data from the player.
Right. And so let's say they have a score. They might also have what? Stamina. They might also have, I don't know, HP. So we get all them, we get all three of them. Then what? So you get all those. You just want to check all those against that. What if my object also has a, I don't know, what else might it have? Might also have what? Might have something like, what else could an object have? What else what other properties could a gold coin have? Could it have poison? Maybe it was enchanted or cursed or something? Maybe? What other properties can things have that you've picked up?
Weight.
Weight. Yeah, maybe there's some encumbrance calculation, right? Oh. Weight. Right? Maybe the player has weight as well. The player's weight? Maybe. Do you want to add the gold coin's weight to the player's weight when they pick it up? Maybe, if that's how you're doing your system. So what's that code look like? You see what I want you to do? Yeah. Loop through both and match by name. To do. You do it.